All right, welcome to our intro video on the flipped classroom. This is something we're going to be doing in class here for the next few weeks. I've been lucky enough to work through NKU. We have a grant to study how using a flipped classroom helps students like you do well. So just want to give you a little bit of intro to what it's going to look like and how we're going to be doing this over the next few weeks. You can tell it's very low tech. We've got some whiteboards and some markers and that's about it. So first, what's a flipped classroom? Well, what we would normally do in class, we would work together in class. I would show you some example problems. You would take some notes. We would work some problems in group. We would work a springboard activity, something like that. And then you would go home and you would work problems at home. Whether it's check your understanding problems or ACT practice problems or end of course problems. You would basically be doing the homework at home. You'd be doing the actual math at home. Now in a flipped class, so what we're going to be trying here for the next few weeks, your homework, your assignment every night is going to be to watch a video like this one. And they'll all be on the same spot on YouTube. You'll watch that video at home like you're watching this one. Then when you come to class, you're going to work problems in class. All right? So doing the homework, doing the problems, that's going to be what you're going to be doing in class now. Hopefully the advantage that we think you're going to have is you've got some resources to help you. And I'm sure at some point in time you've learned something in class and it's made sense to you while you were watching in class. And then you get home and you're like, wow, now I forgot what I'm doing. I don't remember how to do this and I have no one to ask. Hopefully in this case, if you get stuck in class now, that gives you an opportunity to ask me how to do those problems, maybe ask a partner or a group member as well. So it's just flipping the idea of, instead of lecture at school, problems at home, flipping that and you're watching the lecture at home like you are now, and then you're working the problems in class. All right? So how is this going to be successful? What are your strategies for success? You have to watch the videos. All right? The videos are where you're going to get the instructions, where you're going to hopefully get the idea of how to do the problems later on. If you don't watch the video, it's just like coming to class and sleeping. And then you go home and you try to do the homework, you're not going to know what you're doing. So it's very, very important to watch the videos. When you watch the videos, don't just sit there and watch the videos and have your music blasting in the background and be watching TV and be texting your friend. Watch the videos just like you would pay attention in class. Think about the problems that we're doing. I'll be working some practice problems with you, some sample problems on here. Take some notes, just like you would do in class. If I'm working a problem out, you should jot that problem down and be working on it yourself. The thing that's better, I think, than having this in class is you can pause whenever you need to pause. Oh, I need another minute I'm going to try this problem. I need another minute. You can pause and do that. I didn't quite catch that. I'm going to rewind it. Boy, I watched the end of that and I feel like I know what I did. I can rewatch the whole video if I want to. All right, so you've got a little bit more flexibility with actually seeing what's going on and understanding what's going on. What I intend to do along the way is I might write a problem up here and just say, hey, pause it now. I'd like you to try this problem. And rather than just me sitting here for a minute of dead air, I'll just say, you pause it, and when you're ready, you start back up. Make the video a little bit shorter and let you work at your own pace. In order to make sure you watch those videos, so that is the key, you have to see the videos to know what you're doing. We're going to have a little video quiz at the beginning of every class. The quiz, I'm just thinking maybe like 3 questions or so. And it'll be about some of the basic ideas that we talked about in the video. Like I might ask you in this one, what is a flipped classroom? We just talked about what's this flipped classroom idea all about. It may be an actual problem, like a problem that we solved in the video or a problem similar to one we solved in the video to see if you're understanding based on watching it. It could be something that has nothing to do with math. I know these videos might get a little boring from time to time. I'm going to try to avoid that, try to keep you a little bit focused and try to keep you a little bit interested. Something as basic like, hey, every one of these whiteboards I've been writing with a red marker today. Right? Red marker. I'll probably ask you on the quiz for the intro video, what color marker did I use in all these? So just things like that. Not to trick you, I'll try to be real clear. I think it'll be obvious when I'm throwing something in there. But just so that you watch the videos and I can make sure that you're progressing along and watching the videos. It's okay if you don't understand everything from the video. It's just like class. You know, sometimes the first time we talk about it, you're not going to understand all of it. That's okay. But it's important to get that base, and you can come in and say, look, well, here's the problem, and I wrote down in my notes what you said, and I'm not following. I don't know where this step came from, or I didn't get this part of it, and we can work through those things. But it's really, really important to watch the videos. Right? All right, so that's sort of the basic idea of how these things work and how the videos will work. I wanted to throw a little bit of math in at least to kind of get you used to doing some math on the videos. So I'm going to talk a little bit about finding x-intercepts, and hopefully this is something that you're a little bit familiar with already. Finding an x-intercept, what we want to know, in other words, if we have some kind of graph on this coordinate system, on this graph, where would that graph cross the x-axis? Right? And so I'm going to do a little magic trick for you, I guess. So what I want you to do is I want you to pick a point somewhere along the x-axis. Right? Just pick any point you want. It could be one of the points I marked here, or you can go on further this way, you can go on further this way. Pick a point somewhere on the x-axis. All right? And what I want you to do is think about the coordinates of that point. In other words, think about what's the x-coordinate at the point that you picked, and what's the y-coordinate that you picked. All right, so do that now. And if you need to pause, go ahead and pause. Come up with some point on the x-axis, because that's what an x-intercept is. All right? And you've got your x-coordinate, you've got your y-coordinate. All right? What I want you to do, I want you to look directly at the screen, and I want you to think about your y-coordinate. I want you to think about what your y value is where you cross the x-axis. As you look at the screen, I'm going to read your mind. Okay, I got it. Your y-coordinate was 0. All right? Yes, I am. Magic? Not really, because no matter where we are on the x-axis, the y-coordinate's always going to be 0. And if you picked this point, it was 1, 0. If you picked this point, it was 2, 0. You went way out here, this 1, 2, 3, 4, 5, 6, 7, this was negative 7, 0. It doesn't matter what place you choose on the x-axis, the y-coordinate's always 0. This is a really helpful thing. X-intercepts always happen when y equals 0. That can help us find x-intercepts of an equation using that fact. For example, this is our last slide of the day, our last whiteboard. One problem to work here. What's the x-intercept of the line y equals 2x minus 6? We've graphed lines already. We know about slope. We know about y-intercept. Here I'm asking about x-intercept. Well, think about the magic trick. Think about the point that you picked. What do you know about the x-intercept of this equation? What do you know about the y-coordinate? It's got to be 0, right? So in order to find the x-intercept, all we have to do is substitute 0 in for y. Right? So we're going to put 0 in for y there. And now we're going to solve that for x to find the x-intercept. We'll add 6 to both sides. We'll divide by 2. And we find that our x-intercept is at x equals 3. So if I were graphing this line, and again, we know a lot about graphing lines already because we know about slope and y-intercept, we would know this graph crosses the x-axis where x is 3. 1, 2, 3. We'd have an x-intercept there. From there, we could use slope, or we could choose some other points and graph the rest of that line on our coordinate plane. So that's the big idea math-wise here, is to find an x-intercept. We're going to always make y equals 0. Hope this first video made sense to you. Hope you remembered the red marker. Hope you enjoyed the magic trick. After we do our little intro in class tomorrow, we'll start getting into how to use this idea of finding x-intercepts to solve some things that aren't straight lines and look at some different graphs on. So, hope you enjoyed the first video. I'll see you tomorrow.